We have a violent tornado on the ground. Actually, we have several violent tornadoes on the ground heading towards Birmingham. What do you see here? What you're seeing here, this is a debris signature. This is debris, basically. What you're seeing is debris that's being lofted in the air. That's hail with an embedded debris signature that is currently bearing down on Birmingham. Birmingham, if you are... Oh, sorry. Birmingham, get underground immediately. Currently, it's bearing down on the town of Wilton, Alabama. Very violent tornado on the ground right now. This is a very, very life-threatening situation. We have a violent tornado on the ground right now. This is a violent tornado. This is not just a small tornado. This is violent. Hopefully it will weaken. I mean, but there's the problem. This is a discrete cell. This tornado is not a squall line. These are the supercells that went ahead of the squall line. These are legitimate supercells. And with all the wind shear that is available, these tornadoes can become really powerful. In fact, we have another hook developing, another area of rotation just to the southeast of Marion. So there's basically could be a series of tornadoes that could hit Birmingham tonight. If you are in Birmingham, you need to be in your safe place now. These storms are rapidly moving northeastward towards the metropolitan area. And that's not the only storm you need to worry about. We have a even more powerful, seeming like a hook echo. Let's see. Yeah, we have another powerful hook. This is along the squall. And look, there's debris with it too. So we have multiple tornadoes on the ground. We have multiple violent tornadoes on the ground. Yep, look at that. Look at that. Boom, right there. Look at that debris signature. We have violent tornadoes on the ground heading towards the Birmingham metro. And we have another tornado that's just northwest of Brookwood, also heading towards the Birmingham area. I mean, we have two confirmed tornadoes. We have already two confirmed tornadoes. One west of Brookwood, northwest of Coaling, heading towards the northern suburbs of Birmingham. And we have another tornado. Hopefully it's weakening. I mean, there are some indications that this could be weakening. So we have a possible weakening tornado right now. So, however, with this hook being so intense, I'm not thinking it's going to weaken. Also, you got some hail with this. Here's your debris signature. Yeah, that's debris. It's still on the ground. Based on what I can see, it's on the ground. Yeah, there's debris falling out of the air. That is a lot of debris, folks. That is a lot of debris. Jesus Christ. Goodness. Whoa. Coming from. Weather Garrett, all right. Let's see. Well, that tornado is currently weakening. Weather Garrett. Jesus Christ. Well, it looks like a weekend for now. Jeez. Whoa. Yeah, that is a very powerful tornado. That is really powerful. Jesus Christ. I mean, if we could only look at the velocity when that tornado occurred. Holy crap. It's finally gone. Oh my Lord, it's finally lifted back up. All right, yeah, that's hail. Yeah, so that discoloration you're seeing, that's probably hail. Anyway, I'm back. So I'll be gone for a few minutes. I'm gonna resume. So it's going to for about 10 minutes. There's going to be some lagging, but. We got a problem now. Big one. We literally just had twin tornadoes that went. Oh, never mind. We're about to have a new tornado to form. Come on, National Weather Service, get on this cell.
My father and his mother. His father, my uncle. Tycho. His mother, Tycho's mother, and his wife's mother.
It's pretty obvious this cell is going to make it to Birmingham first.
Mother and father, because
his mother, Rosa.
Anyway, we have a situation in Mobile.
Robert's father's mother.
Well, we had a situation in Mobile. Actually, we still do.
The sisters.
We had twin tornadoes.
The first cousins who get married.
Boom.
That guy didn't come out because.
This could be forming a new tornado, though, right here. Yep. It's on the ground again. We have a new tornado. We have a tornado on the ground right now, just north of Mobile. Oh my God. This is bad. This is really, really bad. Load. This is where the tornado would be, right here. Bingo, and this is where your tornado would be. Come on, Sean. Okay, I'm gonna have to message David Schlotthauer right now. We have an emergency right now. You're kidding me. Oh, thank God. I thought that was a tornado. Oh, okay, that's just hail. That's just hail. Could be a brief tornado that spun up, but more likely that's just area of like almost no rain. See how there's, yeah. They're spinning up so freaking easy. Are spinning up so easily. All right, tornado has lifted for now, but any one of these areas can start rotating because look. You're having stuff that can change like every few seconds. Покупаете? Откуда вы мясо покупаете?
Мясо?
Да, вот эти.
Что, не нравится? Самое вкусное мясо.
Но я из этого спрашиваю, я хочу узнать где.
Здесь мясо самое лучшее в мире, брат. Так что не спрашивай, хочешь, скажи, мы тебе закажем, что хочешь, брат.
А?
63-я чебуречная есть? Там,
Оттуда?
мой брат. Он режет корову.
Твой брат?
Потому что я... Well, as I said, sorry, I was just eating at a restaurant. I just had dinner, so heading back home. Yeah, I ate kind of late, but here's the thing. I go to bed around like 3 a.m. in the morning, so I usually eat about 2-3 hours before I go to bed, which is normal. You know, you usually eat dinner at 6, go to bed around 9:30. Problem is, if you go to bed as soon as you finish eating, you can get really sick. And yeah, it looks like another tornado is about to touch down. You see how these areas of rotation are coming together and consolidating? That's because of the low-level jet, which is coming in from the south, and yet your winds aloft are coming in from the west, from the southwest, and that's causing a wind shear. And you can almost see how the thunderstorm taps that wind shear. See how the southwest motion was kind of further away from that fast southerly motion, especially with those downdrafts, but now they're combining. You're having these outflow winds. You're having these very strong outflow winds, basically downdraft, and then you're having that northerly wind. So you start getting rotation. It tightens up the rotation. These converging winds, usually downdraft winds, usually the RFD is what gets a tornado going. The rear flying downdraft is usually what causes a tornado to touch down. Still no debris as of yet. There is no debris yet. However, that could be debris. But the thing is, it's kind of further away, like it's more to the northeast. So that can either be debris, or that can just be some hail. But I'm thinking that could also be like hail. Yeah, it's probably hail. You see how it just looks like it's a hail echo, basically. Anyway, New York City doesn't usually get severe weather in the spring. Our severe weather season is actually you usually get a severe weather season in like June and July, because you still get cold fronts. Like June and July, you get severe weather. And then if you get like stationary frontal boundaries, you could get a derecho, you can get some severe thunderstorms. Climatologically speaking, our main severe weather season has historically been July, August, and September. But now, with the planet warming up, you can push that to November. You can say July, August, September, October, November now could be our severe weather season, especially if the ocean is really warm. New York has a very active severe weather season, June and July, especially late May. Late May, you also get severe weather in New York. Like you can also say late May for New York can also be severe weathers. June and July. For us, it's probably instead of the historical months of the Midwest, April, May, June. For us, we can now basically say it's June, July, August, and September is basically our severe weather season. Oh my God, that's so scary. Holy crap. Woo! That scared the shit out of me. Woo! I've never seen the lights on down here. Ooh. Like the fact that it's dark, wow. I just walked over a grate. It's got to be like a 20-foot drop. Holy shit. Yeah, I heard somebody down there. I've never seen the lights on there. Yeah, it probably means someone's down there. The fact I could see how far down that thing goes, that's scary to me. Like, holy crap. Yeah, I walk over that thing all the time, but I had no idea how far down that went. That is like, oh my God, that's like crap your pants scary. Oh my God. Well, the good news is that looks like the tornado didn't materialize, but that was really close. I mean, you can see how close that came to producing a tornado. Anyway, I'm going to change gears a little bit and start talking about some volcanic activity. There was actually some earthquakes at Yellowstone. Just the other day, I made a live stream last night. It was a fairly modest swarm, nothing too crazy. Your strongest was about a 2.6. Initially reported as a 3.1. And there was some quakes that were not reported. However, Yellowstone is very notorious for forming those rapid fire swarms. And here's what's causing those rapid fire swarms. I'm going to be honest, it's magma breaking rocks underground. It's the rhyolite magma breaking rocks. That's why you're not having harmonic tremors, because rhyolite is very, very viscous. Even underground, you would usually get plutons forming. Basically, formations of magma that solidifies underground. It never makes it to the surface as magma. And if you ever get enough erosion, you'll get an exposure of a craton, basically. So when magma solidifies underground, you basically get either a pluton or a craton. Fairbanks is actually a craton, and they've detected magmatic earthquakes under Mount Denali in Alaska. Why have they detected volcanic quakes? That is because Mount Denali is actually volcanic in origin. It was not created the same way the Rockies were, which is orographic uplift. Which is caused by. It was actually formed by the subduction of the Pacific plate underneath the North American plate, same way as the Aleutian Trench, because the volcanism of the Aleutians runs directly underneath Mount Denali. And the fact that you're having volcanic earthquakes, they're signals that Denali is volcanic in origin. It is. But the only difference is Denali never erupted on the surface. You never had volcanic eruptions that breached the surface. Instead, you basically had a craton that solidified on the ground, and because the ground was uplifted, the current peak of Denali is exposed. But at one point it used to be on the ground, but it was exposed because of glacial activity. You had enough erosion that glacial activity exposed Denali. Is it possible that Denali could one day explode because of all that pressure that the craton is forming? Not very likely. Like Denali, as I said, it's not a volcano. Mount Denali, as I said, is basically a slug of solidified magma, most likely andesite to rhyolite in composition. The reason it's solidified is because the magma didn't have enough mass to erupt explosively. So it solidified on the ground, which meant that the mechanism feeding that probably shut off. I mean, if you're getting, say you see a renewed influx of magma into Mount Denali, like a lot of magma, most likely you would get an eruption, but it probably won't be from Denali itself, because Denali is not a volcano. So what you would get, you probably would get a vent open up, maybe on the peak or off the peak, but most likely the craton would probably block the magma. And if there's enough pressure that builds and builds and builds and builds over hundreds of thousands and most likely tens of millions of years, you could get a caldera forming eruption. And if Denali happens to be at the site of that caldera forming eruption, then you could say that Denali is a volcano. But Denali is technically not a volcano. For example, when you had the Rocky Mountains that happened to sit where Yellowstone is right now, the caldera, those mountains were not formed by volcanic activity, but then they became part of a volcano because of the migration of the North American plate underneath the Yellowstone hotspot. The Yellowstone hotspot was directly responsible for the Columbia River flood basalts. So Yellowstone, I always theorized that the Yellowstone hotspot was responsible for the Columbia River flood basalts, though I couldn't really find any good research papers on it, but Geology Hub confirmed my suspicions that the Columbia River flood basalts, because once I traced the path of the North American plate, perfectly correlated with the Columbia River flood basalts. But the thing is, a few million years after the Columbia River flood basalts formed, like maybe 1 million or 2 million years later, it transitioned from a effusive eruption to a highly explosive eruption, to a highly explosive caldera-forming eruptions that emitted lots of ash and altered the climate around the world. Very much opposite of what the Siberian traps did. Siberian traps warmed the planet to the point of causing a worldwide global extinction level event. But the Columbia River flood basalts, or later known as the Yellowstone Hotspot Trail, caused a lot of periods of global cooling because of the high quantities of emissions of ash and sulfur, which cooled the planet. So yes, the Columbia River. No, bathroom first.
Hey, New York! With Cheap Caribbean, all-inclusive means more food. You're free to eat what you want, whenever, wherever. With Cheap Caribbean,
of the Columbia River flood basalts began during the Within Oregon, floods are a relatively common hazard which the area experiences after years. Oregon and Washington were repeatedly buried by floods of lava, which in some locations measure more than 13,000 feet thick. These floods were part of a rare type of volcanic eruption termed a flood basalt. Flood basalts represent the largest known effusive eruptions in the history of the planet and are frequently correlated with mass extinctions. This video will discuss these series of eruptions termed the Columbia River flood basalts, which permanently changed much of the landscape in the United States Northwest around 16 million years ago. The Columbia River flood basalt eruptions began 17 million years ago when the top of a mushroom-shaped hotspot in the mantle, termed the Yellowstone hotspot, permeated a large volume of magma into the crust. This hotspot soon began producing dozens of unusually voluminous shield volcanoes in far western Idaho and eastern Oregon and Washington. However, activity soon changed as eruptions grew more and more voluminous. Instead of originating from a single vent, eruptions now originated from massive fissures, sometimes surpassing 100 miles in length. The entire length of these long fissures erupted during individual flood began. During the subsequent period of activity, a 150-kilometer or 93-mile-long fissure opened up in far southeastern Washington state. Soon, the entirety of this fissure began erupting lava, outputting 2,944 cubic meters per second. For comparison, this is comparable to approximately 1,000 simultaneous Kilauea volcanic eruptions in Hawaii occurring at the same time. Over a period of 14 years, this eruption continued, flooding a large swath of Oregon and Washington state in molten rock. By the time this individual eruption had ended, an area equivalent in size to the combined states of New Jersey, Delaware, and Connecticut had been covered in up to 500 feet thick of lava. Individual lava flows from this single eruption traveled up to 200 miles distant from its source vent, marking a truly impressive eruption. In total, 1,300 cubic kilometers of molten rock was emplaced on the surface in this short time span. Eruptions like the one just described were repeated in both Oregon and Washington an average of once every 3,400 years for the next 1.1 million years. 93% of all the lava which would be eventually emplaced by this flood basalt was emplaced during this time span, after which eruptions became far less frequent. Individual flood basalts soon began occurring once every 10,000 years, then 25,000, then 50,000 years. By 15 million years ago, 98% of the total lava which would be output had already been emplaced. For the next 10 million years, far less frequent residual eruptions created a series of smaller volume flood basalts, which even sent flows of lava into northern Nevada. The last such large volume eruption occurred 5 million years ago, by which time the Yellowstone hotspot was centered in eastern Idaho, as eruptions from its mantle plume were now highly explosive and The last such large volume eruption occurred 5 million years ago, by which time the Yellowstone hotspot was centered in eastern Idaho, as eruptions from its mantle plume were now highly explosive and the last such large volume eruption occurred 5 million years ago, by which time the Yellowstone hotspot had already been years than 25,000 feet thick. These floods were part of a rare type of volcanic eruption termed a flood basalt. Flood basalts represent the largest known effusive.
First caldera of the
These floods were
Yellowstone
part of a
sequence.
rare type of volcanic eruption termed a flood basalt. Flood basalts represent the largest known effusive eruptions in the history of the planet and are frequently correlated with mass extinctions.
Doesn't that look like a flow of,
This video will discuss these
water,
series of eruptions termed the Columbia River flood basalts, which permanently changed much of the landscape in the United States Northwest around 16 million years ago. The Columbia River flood basalt eruptions began 17 million years ago when the top of a mushroom-shaped hotspot in the mantle, termed the Yellowstone hotspot, permeated a large volume of magma into the crust.
Subduction.
This hotspot soon
right
began
side.
a hotspot in the mantle,
So
termed the Yellowstone hotspot,
that's
permeated a
See, towards the left, that's subduction-driven volcanism, and on the right side, that's the Yellowstone hotspot.
large volume of magma into the crust. This hotspot soon began producing dozens of unusually voluminous shield volcanoes in far western Idaho and eastern Oregon and Washington. However, activity soon changed as eruptions grew more and more voluminous. Instead of originating from a single vent, eruptions now originated from massive fissures, sometimes surpassing 100 miles in length. The entire length...
The thing is, the Bruno Jarridge caldera, the McDermott caldera, was actually formed around at the same time as the Columbia River flood basalts. So you were having flood basalt volcanism while at the same time you were having supervolcanic eruptions. Because, thing is, the flood basalts were occurring in an area with low silica content in the crust, while the McDermott caldera, the hotspot, was under an area with high silica content in the crust. So some of the individual magma chambers were mostly located in an area with low silica content, but the McDermott area was located with an area with high silica content. So as a result, you had a lot of silica that leached into the crust over, probably a few tens of thousands of years. And pressure built because the magma was very viscous and didn't erupt easily. And it all released all at once. So, while you're having multiple flood basalt volcanism events every few thousand years, you wouldn't think there was any volcanism under the McDermott area. You might have had some lava domes forming. You might have had a lot of earthquakes, some hot springs, but you wouldn't think that there was going to be such a huge eruption. But eventually, the gas and pressure built enough that the first of the Yellowstone hotspot calderas formed, the McDermott caldera.
Long fissures erupted during individual flood basalts covering immense amount of land and molten rock. Beginning around 16.7 million years ago, the peak phase of the Columbia River flood basalts began.
See, peak phase of Columbia River flood basalts, 16.7 million years ago.
During the subsequent period of activity, a 150-kilometer or 93-mile-long fissure opened up in far southeastern Washington state.
The Idaho border.
Soon, thousands and molten individual in total 100 years for them became far less. By 15, became far less frequent. Sent flows of lava into northern Nevada. The last such large volume eruption occurred 5 million years ago, by which time the Yellowstone hotspot was set.
See, 16.39 million years ago. So, the peak phase was
in eastern Idaho and sent flows of lava into northern Nevada. The last such large volume eruption occurred 5 million years ago, by which...
Look, 16.7 and 15.6 million years ago. So the thing is, the McDermott caldera formed right in the middle, or in the beginning phase of the Columbia River flood basalts. And
Yellowstone hotspot sent flows of lava in years, then 25 flood basalt was in place during this 100 years for the next 1.1 million years. 93% of all the eruption.
So, McDermott occurred 16.39
from its
million
source
years
vent,
ago.
marking a truly impressive eruption. In total, 1,300 cubic kilometers of molten rock was emplaced on the surface in this short time span. Eruptions like the one just described were repeated in both Oregon and Washington an average of once every 3,400 years for the next 1.1 million years. 93% of all the lava which would be eventually emplaced by this flood basalt was emplaced during this time.
Columbia River flood basalts. well, most figures 17 to 14 million years ago. Mahood, 2012. That's two people who funded the research. See, Mahood, GA, and Cable. See, you can actually see the affiliations right here. See, there. It's been long known that Angambrites from McDermott Caldera Field, or MCF, and High Rock Caldera Complex, HRCC, erupted at nearly the same time, but the relative stratigraphic relations have not been previously determined. A west dipping section on the west flank of the Pueblo Mountains contains 4 Angambrites stratigraphically above Steen's basalt. A non-welded metaluminous rhyolite Angambrite at the base of the section is chemically distinct from the weakly alkalic to moderately peralkaline rhyolites from McDermott Caldera Field and High Rock Caldera Complex. This Angambrite is similar in composition and mineralogy to lavas from the Hawks Valley Lone Mountain Center, north of the High Rock Caldera Complex. Okay, basically, what they're mentioning is that there's possible that there was consistent propagation of Columbia River flood basalts. And Doug Demure, Geology Hub mentioned that it continued until 5 million
River
years ago.
flood basalts began. During the subsequent period of activity, a 150-kilometer or 93-mile long time span, now highly explosive, and the last such large for the next 10 million years, far less frequent residual eruptions create a last such large volume eruption occurred 5 million years ago, by which time the Yellowstone hotspot was centered in eastern Idaho.
So the thing is, there were eruptions and it was forming one supervolcanism in Oregon related to the Yellowstone hotspot. Residual volcanism.
The last such large volume eruption occurred 5 million years ago, by which time the Yellowstone hotspot was centered in eastern Idaho, as eruptions from its mantle plume were now highly explosive instead of effusive, creating large supervolcanoes such as the modern Yellowstone caldera. During the 12 million year long time span, 210,000 now highly explosive instead of effusive, creating large supervolcanoes such as the modern Yellowstone caldera. During the 12 million year long time span, 200 now highly instead of effusive.
Oh no. We have a possible tornado going towards Montgomery now. Seriously, it's like oh, come on. Okay, that doesn't look too bad. At first it was like, oh my god, it's a tornado, but that was just a little glitch in the radar. Anyway, there's a lone severe thunderstorm warning in Tennessee. Yeah, most likely for winds. There's some probably pretty strong winds with this system, looks like. Yep. And let's look at tomorrow. It doesn't look too bad. Using damaging winds and occasional tornadoes. A 60 knot, southerly 850 millibar jet is overspreading the southeast into the Ohio Valley, where the exit region of 100 knots westerly 300 millibar jet streak is also by a large tornado. You had several strong cells that there were some really to do a search and rescue operation. In Friendsdale Bar and Grill. Just want to make sure I know what that is. Looks like that was a 3 or a 4 at least. Yeah, and the Mayfield tornado had debris over 40,000 feet, which means it might have been an EF5. Mm-hmm. Anyway, yeah, extraordinarily. Yeah, that's actually, he's kind of like saying that's not normal. And it's even crazier. Why didn't all this rain just stop the tornado from forming? Yeah, because you had a lot of shear, a lot of instability. It's really sad. It's stratiform rain. But it would have been raining. Of the storm. Yeah. Super rare. Kind of like need strong 0 to 1 days like Jarrell. Yep. And that tornado formed on the day with little to no shear. It was an F5 tornado that formed with almost non-existent shears. Like, I'm just gonna feed off the other storms. And it wasn't May, actually. Wasn't the Gerald tornado like stationary? So it wasn't May Day. So you basically had very low helicity at ground level. Well, tornadoes. Yep. Tornadoes. Yep. Man. You had supercells forming in a shield of stratiform rain. You had a supercell form in a stratiform rain. Of moderate stratiform rate, of moderate. Wow. Yep. Yeah, the rain didn't do anything to stop that supercell from forming. Yeah, so basically, you had a shield of stratiform rain. It didn't stop the supercell from forming. Supercell was like, I don't care. I'm going to form whether it's raining or not. Imagine if it wasn't raining, yeah, the storm supercell would have been even stronger. But the thing is, stratiform rain didn't really make that atmosphere much less stable. So it was like, it was probably going to happen anyway, whether it rained or not. In fact, when we had Ida in New York, we actually had several EF3 tornadoes. We had an EF3 tornado in New Jersey that formed in a stratiform rain area. And actually, yeah, there were some tornadoes, and one tornado almost formed right in Long Island. In fact, I'm going to go to one of my videos. This was taken on November 13th. The video quality is really bad, but because I should have recorded. This is why from now on, if there's severe weather, I'm going to be recording then uploading. Yeah, basically, it's just the quality of the video would be much better if I record then upload than if I stream during a storm, because streaming during a storm would probably, the internet service would probably be messed up, and a lot of y'all probably won't even see my stream in the first place. So from now on, during severe weather, I will be recording instead of streaming. I may stream during snowstorms, but not during severe weather events. Okay, alrighty, your channel. It still shows I'm streaming. See right here, Birmingham tornado. I'm gonna change that right now. Alabama tornadoes. Tornadoes. All right. Yeah, that's when I saw 13 inches of snow in New Jersey. Yeah. Jeez. Yeah, basically that I've been trying, you see how it says Hurricane Laura forecast? Problem was that I've been having those issues. There it is, NYC hailstorm. Okay, let's go to the beginning. That's actually the wall cloud approaching. That's actually the wall cloud. What you're seeing there right now is the wall cloud. That cell ended up producing a tornado. Yeah, I was having a field day, basically. Yeah, just as I... Yeah. It happened because there was water on the screen, and you see that little thing on the bottom left? But the thing is, you had very cold air aloft. Temperatures were very cold. Like in New York City, it was like in the low 60s, but in Long Island, it was in mid 60s. Because you had very strong winds off the water, and the water was still pretty warm. It was unusually warm most of that spring. Basically, it was so... So yes, basically, November 13th, Long Island had multiple tornadoes, had 6 tornadoes, several EF0s and a couple EF1s. The thing is, there were twin tornadoes that were right near the National Weather Service office. And yes, Tiff 48 was actually tweeting about, because I tweeted to her about the twin tornadoes. In fact, what I need to do is go to my Twitter. There we go. Profile. Tweet and replies. Let's go all the way down. Let's go all the way down. Yes, tweeting about Ukraine. This is back in February. Okay, now I'm still in February. I did a lot of basically hacktivism, or what's the word for activists who are online? Like, yeah. Great. All the way down. Yes, I'm going to go all the way back. Let's go to November. Come on. Quad State tornado. Yeah. The Quad State tornado just doesn't want to die. It's still kicking. Tornadoes heading towards Bremen and Sacramento, Kentucky. Yeah. That's debris. Everything you're seeing here is debris. That's debris. That's basically debris that's being lofted. It's even ahead of the tornado warning. So yeah, even... No, it was not. Actually, you spelled Elliot's last name wrong. It's Paige, not, or maybe that is how you spell it. Elliot Page. I think it's maybe it is Page. Great. So the spelling is indeed correct. Okay, let's move on from that. And how the hell did I just... Great. Now I have to go all the way down. Boom. I have to go all the way down to December 11th. Ahungatunga. Oh yeah. This could be a VI6. Truth is, the eruption is mostly over by now. But let's zoom in a little bit. Wow. Spread in both directions. It went... You even had an easterly propagation. It definitely went into the stratosphere. amazing. Yep. That is definitely Hunga Tonga. I meant to write tsunami imminent. Well, actually, that was a little puffer. The main eruption had actually already happened. See, even after the main event, you still had some more eruptions. Thank you for coming. Yes. Ugh. I just saw two rockets. I just saw two bodies really close to each other, just passing by. We got a launch. Got a launch from Cape Canaveral. Actually, I've actually seen launches from Cape Canaveral. I remember looking south and I saw the separation stages all the way from New York City. Or that may have been not from New York City, but from, yeah. What? Currently getting light snow in Astoria. Temperature is 40 degrees right now. Poor visibility towards Manhattan because of the snow. I'm currently in Astoria where there's some light snow coming down. Looking towards Manhattan, visibility looks very poor because there's some more snow coming in from Manhattan. In fact, I can barely see the skyscrapers. Look at that. Those are the buildings up there. You could barely actually see them over there because there's snow coming down. It's light, but there's enough of it that it's lowering the visibility. Temperature right now is about 39, 40 degrees, which normally is too warm for snow. However, there's enough cold air aloft, and there's enough cold air, right just a few hundred feet up, that snow isn't melting before it reaches the ground. Roads and exams. I'm pretty sure he passed. Yep, November 13th. Look at Brookhaven and Bellport. Look at this. Twin tornadoes. Bingo. Boom. Twinados, yep. And the National Weather Service also only said, it's two separate debris signatures, yep. It's true. Got to breathe. Sycamore leaf. And then the next day it happened. Tornado. Anyway.
Каких-либо дополнительных комментариев?
От ресторанов в России продолжают оказывать услуги посетителям. Они работают на условиях франчайзинга под управлением российских предпринимателей. Это около 20% заведений Макдоналдс в стране. В Москве точки американской сети открыты на транспортных узлах: Шереметьево, Домодедово, Ленинградский вокзал.
Для нас ничего не изменилось. Мы франчайзинговая организация, работаем в прежнем режиме. Планируем работать завтра. Каких-либо дополнительных комментариев дать, к сожалению, не могу.
В столице можно сделать заказ с помощью сервисов доставки. Корпорация «Макдоналдс» объявила о временном закрытии находящихся под ее управлением 850 ресторанов в России из-за боевых действий на Украине. Ажиотажа на Ленинградском вокзале нет.
Мы очень любим Макдональдс, это наше любимое заведение общепита, и пришли именно сюда, потому что оно здесь открыто.
Ну, мы случайно увидели, мы уезжаем в Санкт-Петербург, у нас все не работают в Макдональдсе, ребенок любит, и в принципе, да, из фастфуда всегда выбираем Макдональдс.
Власти Москвы сообщили о выделении дополнительных средств на льготное кредитование для создания дополнительной сети быстрого питания, которая придет на замену закрывшимся точкам. Больше всего франчайзинговых Макдональдсов в России расположено в регионах, например, в Сибири.
Siberia, okay. Basically, what they're saying is that they're... Let me rewatch the video. I just want to hear what she's saying.
России продолжают оказывать...
Leningradski. All right. Great. Anyway, I'm gonna start. Okay, yeah. Usually I have to start like it's kind of weird.